So, in more general terms, the to more closely define the summation notation, what we're talking about is if we had a sequence that was, a sub 1 plus a sub 2 plus a sub 3 plus all the way to a sub n, right? Whatever the sequence was, we're adding each term together. That creates a sum, all right? So we're going to use the summation notation symbol, sigma, and then we're starting at 1, and we're going to say k equals 1, and it goes till n of a sub k. All right, so whatever the sequence is, define each term and add them together. And again, I said before I would write this out, but the k is called the index. It actually doesn't have to be the letter K. I've seen them use like I or J. But what I sometimes confuse is I would call that N, but then I don't actually have an N to reach as my nth term. So don't use N, but you can use other letters, but usually you'll see K as the first one. And then what this means is the sum of a sub k from k equals 1 all the way to n. Okay, so this is just the general equation for it. All right, so for example, if we're given the sum from k equals 1 to n of 1 over k, okay, this is what we're given, then we could expand this out, okay, and we would say, well, k equals 1 to begin with, and then 2, 3, 4, etc., all the way to n. So this sum, this is what it means. 1 over 1, so that's 1, plus 1 over 2, plus 1 over 3, plus all the way to 1 over n. Okay, so that's defining the sum. Another example, if we have the sum from k equals 1 to n of k factorial, okay? So we know that factorial means that we're going to be multiplying, like 3 factorial is 3 times 2 times 1, right? So this is the sum of each factorial starting with k equals 1, right? So this is 1 factorial plus 2 factorial plus 3 factorial plus all the way to n factorial. Probably keep a plus sign in there. Okay, so that's what the sigma notation means. Next, we're going to actually start finding the sums, like actually finding the number that the sum will equal.